Hello dear students, let's continue our discussion on equilibrium chapter. So in the live session we have discussed about equilibrium, and now we will discuss on ionic equilibrium by using some PYQ questions. Okay, so here I have a question from acid base series. So here conjugate base for Bronsted acid like H2O is given, HF is given. So what are the conjugate bases for these acids they are asking. So this is from acid base theories, right? So here if H2O is a conjugate like Bronsted acid, then it will releases one H plus ion, and the negative part from this is called its conjugate base. If this is an acid, then this will be the conjugate base of this acid. Okay, so this is the conjugate base of H2O. Similarly, HF we have, from this release one H plus ion if it is an acid, so it will release as H plus and forms F minus. So this is what the conjugate base of this particular acid. Okay, so these are the two conjugate bases. So choose the option which are having these two options. See, option 3 is having OH minus F minus. These are the conjugate bases for these two Bronsted acids. I hope it is clear, and I have a special video made on acid base theories, Arrhenius acid base theory, Lewis acid base theory, Bronsted acid base theory. You can watch it after completing this session. Okay, that will give you more clarity on acid bases. Okay, and the next here we have the aqueous solution of HCl has pH 4. pH of this HCl solution is 4. Its molarity will be. So what is the formula of pH? pH equals to minus log concentration of H plus ion in normalities. This is a formula. So if pH is 4, if this pH value is 4, here I am writing minus log concentration of H plus. Okay. Now see, send this minus and log to this side. So what happens? It will become, log becomes base 10. So 10. So minus, it will become minus 4, like this we should write. So this will be equals to concentration of H plus in normality. See, for HCl N factor is H plus and Cl minus we are getting now. So N factor for HCl is 1, therefore normality equals to molarity, because what is the relation between normality and molarity? Normality equals to molarity into N factor. Okay, molarity into N factor. So N factor value for HCl is 1, therefore normality equals to molarity into 1. So it means normality molarity are equal. So normality molarity for HCl is equal. So what is the concentration we got for this? That is 10 power minus 4. So here see, 10 power minus 4 means this is the appropriate answer, right? So look here, I hope the option is clear, the third option. So having 0.0001, which is 10 power minus 4. So option 3 is correct for this particular question. I hope there is no confusion in this discussion, right? Next, pH plus pOH is equals to what? They are asking at 25 degrees. Okay. Now this is also very easy and important question based on the concept. Here look, H2O, when water dissociates, it will release a H plus and OH minus ion. Okay, so we will get equal number of H and OH ions from one molecule of water, right? Okay, so now the experimentally it is observed that the dissociation constant Ka, I mean Kw for water dissociation constant, we can write like this: concentration of H plus, concentration of OH minus. Okay, so like this we will be writing. Okay, so it is found that experimentally water having dissociation of 10 power minus 7, it means concentration of H plus ion and concentration of OH minus ion is found to be 10 power minus 7. Okay, so this is the dissociation value, I mean concentration of H plus and OH minus ions at 25 degree Celsius, at this Celsius. So this is the dissociation, this is the concentration of H plus and OH minus ion. Okay, overall molecule is neutral because same number of H plus and same number of OH minus are present, right? Okay, so now what is the Kw value? So here we will be getting Kw equals to 10 power minus 14. Now look here, so I can write Kw equals to 10 power minus 14, right? Okay, now apply pH to this, apply minus log to this, I mean pH means like make in the form of pH because they are writing pH plus pOH, no? So I can write for this one. So look here, what I am making is apply both sides, log apply log Kw equals to log of concentration of H plus concentration of OH minus. Okay, like this we can write. So here also it will become log of 10 power minus 14. So this is what we can write now. Now apply negative sign on right and all the sides like this. Okay, so whenever we have something like this, pH means what is the formula we are writing? pH equals to minus log of concentration of H plus. This is what pH. So when we have minus log of concentration of value of Kw, so we can say it as pKw. Okay, which is equals to, whenever we have log A into B format, so we can write log A plus log B. Applying negative sign both sides, we will be getting minus log concentration of H plus, that is what pH. Okay, and minus log concentration of OH minus, that is what POH, which is equals to log minus of log 10 power minus 14 is there. So I can write, if there is something like this, log of A power B, if we have, we can write B log A. So if we write in that format, so it will become 14 log 10. Log 10 value is 1. Therefore overall value becomes minus into minus 14, that will be plus 14. Like this we can write. Okay, I hope this is clear up to here. And the next thing is, what they are asking us here. So at 25 degrees Celsius, pH plus POH is 14. I hope concept is clear now regarding this pH and POH, why it is 14. So now what is a neutral point? So neutral point will be like in between these, because 7 is for pH, 7 is for POH, overall it is 14. So what is the neutral point? At 25 degrees Celsius, it is 7. Okay, now it is found that concentration of H plus and concentration of OH minus, is equals to 10 power minus 6 at 90 degrees Celsius. Okay, this is also experimental observation only. Okay, from this, now what is our pKw value? This will becomes what? How much? This is, see, concentration of pKw means concentration of minus log concentration of H plus minus log concentration of OH minus. It means 10 power minus log concentration of 10 power minus 6 plus minus log concentration of 10 power minus 6. That will be 10 power minus 12 we can get. So that is what? So overall pKw value will be 12. Okay, so this is the value, pKw value equals to 14. This is at 25 degree Celsius. Okay, and this value is at 90 degrees Celsius. See, so what is the difference here? So dissociation is increasing. Here concentration of H plus ion is 10 power minus 7 at 25 degrees Celsius. Here it is 10 power minus 6. It means the value of concentration for H plus ion and OH minus is increased with increase in temperature. So I can say dissociation of water is endothermic process. What is that? Endothermic process. So you can remember this statement also. So it is increase, dissociation of water increases with increase in temperature. Okay, and the value of like pH scale depends on temperature. So pH is temperature dependent. The neutral point of water, on pH scale is 7 when we are taking at 25 degrees Celsius. When we are taking 90 degrees Celsius, the neutral point value will be considered to be 6, because concentration of H plus ion and concentration of OH minus are equal to 10 power minus 6 now. From there we will be getting neutral point as 6 at 90 degrees Celsius. I hope this is also clear, right? Okay, then next we will discuss few more questions here. Which one has pH equals to 12? So how can we answer this? Which one has pH equals to 12? Okay, so what I told you, pH equals to minus log concentration of H plus, right? So pH is 12, so it means minus log concentration of H plus ion concentration is 12, right? So from this, concentration of H plus ion will be equals to 10 power minus 12. Okay, I hope this is clear. So we know, see, whenever they haven't mentioned temperature, so you should, by default you should consider this is at 25 degrees Celsius. Okay, now the product of concentration of H plus and product of concentration of OH minus, how much value here we have studied here? So here we have studied at 25 degrees, it is 10 power minus 14, right? So take it the value over here, 10 power minus 14, right? So what is the concentration of H plus ion from this solution, from the data? 10 power minus 12. Therefore, what is the value of OH minus concentration? It will be 10 power minus 14 into this, so we will be remaining with 10 power minus 2. So what is the concentration of OH minus? We got 10 power minus 2. So 10 power minus 2, where do we have 10 power minus 2? I can write this value as 0.01. Okay, so we have option number 1, because 10 power minus 2 can be written in this format. Therefore, option number 1 is the most correct answer for this particular question, right? I hope it is very clear without any confusion. Next, pH of solution. pH of solution containing 50 ml of each 0.1 mole sodium acetate and 0.01 mole molar acetic acid. Okay, given pKa is given. See, whenever we have mixture of weak acid and salt formed from weak acid plus a strong base, when we have this kind of mixture, so this should be called as buffer solution. So we have weak acid now, so we can say acidic buffer solution. So how acidic buffer is formed? So it is a mixture of, so it is formed from the weak acid plus strong base. So whenever we are taking weak acid, strong base, now in this case we should take weak acid in the excess amount, then the strong base. Okay, when we are taking this excess amount, the resultant mixture will be having weak acid and a salt formed from this weak acid plus strong base. Let me tell you one example here. I am taking acetic acid. Okay, listen here very carefully, because next question is again on this topic only. Okay, and NaOH. So this is a weak acid, strong base, right? This is a weak acid and this is a strong base. So let us say I am taking this as 4 moles, I am taking this as 2 moles. Now what happens? We know acid base reaction takes place, but how many moles we have base? Only 2 moles, but here we have 4 moles of acid. It means these 2 moles completely react with the 2 moles of this acid, and the remaining 2 moles will remain in the solution, in the mixture, right? So now we will be getting a salt of sodium acetate like this. This salt is formed. Here 4 moles, here 2 moles. So this is lesser, na? This is the limiting reagent. So this will decide how many moles of product should be formed. Okay, it is formed. Then next, salt is this one, and we will be getting water also byproduct. Okay, so in this mixture, out of 4 moles, 2 moles reacted 2 moles, and 2 moles unreacted, we can say. So now in this beaker, in the reaction beaker, what are the things we have? So 2 moles of unreacted acetic acid and 2 moles of salt, right? This salt. So this salt is nothing but salt of weak acid formed from weak acid plus strong base. This is a salt of weak acid plus strong base. So this is how you need to understand. So what is a mixture of acidic buffer? It is a salt of weak acid plus strong base and having weak acid along with that salt. I hope it is clear. So once again, so buffer solution, acidic buffer is a combination of weak acid plus salt formed from weak acid and strong base. That is a mixture. So always remember this mixture. Okay. Now whenever we have like this, so how can we calculate pH? So pH of this acidic buffer can be calculated using this formula. I am not giving you the derivation of formula, I am directly writing the formula here. pH equals to pKa plus log concentration of, so this side what we have? We have salt now. So write salt concentration by acid concentration. Okay, this is for acidic buffer. Okay, now I just want you to ask for basic buffer. So basic buffer means how can we expect, what is the combination? So whenever I am saying weak acid, like acidic buffer, so whenever I am saying acidic buffer, you will be seeing a weak acid plus salt formed from weak acid and strong base. So whenever I am saying basic buffer, so you should say that it is formed from acidic buffer means weak acid, basic buffer means weak base plus salt formed from weak base plus strong acid. So take one example, So what is the example? We can say NH4OH, which is a weak acid, and salt formed from this NH4OH and a strong acid, that is, let us say HCl. So here also let us take this is 4 moles. Again, always whenever we are saying weak, whenever we are saying acidic buffer, take weak acid as major quantity, and whenever saying I am basic buffer, take weak base in the major quantity and strong acid in the limited quantity. Therefore, we will be getting NH4Cl plus H2O. Okay, so out of 4 moles, only 2 moles is reacted, 2 moles are remained unreacted. Only these 2 moles are reacted, and in the solution we have 2 moles of what? Weak base plus salt of weak base plus strong acid. So this mixture is called now basic buffer. Okay, so whenever we have basic buffer, the pH is calculated. The pH is calculated like this. Since I am saying basic buffer, you should say POH formula. For acidic buffer, pH formula. For basic buffer, POH formula. So POH equals to pKb. Whenever I am saying pH, take acid dissociation constant. pH equals to pKa plus log salt by acid concentration. Here POH means pKb, this is a base dissociation constant, plus log concentration of salt. Here also this denominator should be base. Here it is acid. I hope the formulas are clear. Now what is the relation between pH and POH? pH plus POH equals to 14. This is at 25 degrees Celsius. We already seen this in the previous slide. Okay. Now for this this particular question we required, this is a amount of the information we required. Okay, because see what they mentioned, pH they are asking of solution containing 50 ml of each 0.1 molar sodium acetate. So salt is sodium acetate. So pKa. So given pKa is 4.57 plus log. What is the like salt concentration they given? 0.1 into what is its volume? 50. Okay, and then denominator, what is the acid concentration they given? So volume is 50 ml. Okay, and what about its concentration? 0.01. So volume I have cancelled out. Okay, so this is being 0.1 at the bottom denominator, so I am taking here as 10. Okay, so in the denominator if it is 0.1 we can take as a 10 in the numerator. Okay, now log 10 is 1, so 4.57 plus log 10, 1 means this will be 5.57. I hope it is very clear without any confusion, right? Okay, so here they are asking about pH, so this will be our answer. If they ask about POH, what we can do for this particular question? So we got the final answer, you can tick this, but my question is, if they ask about POH, so what I can say? pH plus POH equals to 14, therefore POH equals to 14 minus pH. So 14 minus this value gives our POH for this acidic buffer. Similarly, for basic buffers, you can first calculate POH, then convert into pH if they are based on the question they are asking you. Okay, I hope it is also clear. The next, which will make the basic buffer? I told you basic buffer, what is the combination? Will you identify this? Will you take it as a work? See, explained, everything is explained here. So based on this, I am expecting answer from you for this particular question in the comment box. So just write question number 1 in the comment box and option, which option is correct for this particular basic buffer. Otherwise mention basic buffer and tell me the option, therefore I can give you the clarity in the comment box if whether your answer is correct or not. So this is purely based on here, completely we discussed in this slide only, based on that you can solve. Okay, next, here we have pKb of dimethylamine, pK of acetic acid are given respectively. The correct option of pH of dimethyl ammonium acetate. See, dimethyl ammonium acetate, so it is a salt. It is a what? It is a salt formed from this weak base and from this weak acid. So both are weak na. So salt is formed from weak base plus weak acid. So whenever we have a salt of weak base plus weak acid, so that salt will undergo salt hydrolysis, then pH value will depends upon both pK values and pKb values. So pH for this particular compounds, whenever we have weak acid and weak base in the given mixture, the salt will be, the salt pH of the salt will depends upon the values of pKa and pKb values of that particular acid and base, pKa minus pKb. So this is the formula we need to use. So pH plus pH equals to 7 plus half into, what is the pKa value they mentioned? It is 4.77 minus pKb is mentioned as 3.27. Okay, so from this how much we will get? So 7 plus half into, so this is 1.50 and we can say this is 0.75, therefore pH is equals to 7.75. so this will be the value. So we have option number 2 which is given here. Next, about solubility and solubility product. So here you can expect one question from this topic also, whatever the exam you are going to attempt. Okay, so one of the important topic, listen to me. So what exactly solubility? For example, I have a container here, beaker. So in this I am adding a particular substance. Okay, let us say I am adding a sparingly soluble salt. It means it is having very low solubility. Okay, so when I am saying it is having very low solubility, so let us say here we have a solvent. So to this solvent I am adding this solute. Okay, that sparingly soluble salt. Okay, so now only some amount of that salt will be solubilized in this solvent, remaining will remains undissolved, like it will be like a precipitation form in the bottom of that beaker. So only small amount is undergoing like solubility, right, undergoing dissolving, but remaining will remains as precipitate. Okay, so now the amount of substance, the amount of solute that is dissolved in that solvent is considered to be its molarity, or it's considered to be its solubility. The amount of substance that is dissolved in the solvent is what? Its solubility, or we can also call it as molarity. Therefore, what is the units for solubility? I can say mole per liter. So this is a unit for solubility here, or you can simply say molarity is a unit of solubility. Okay, the amount, the number of moles of substance dissolved in 1 liter of solution at a given temperature is termed as solubility. I hope it is clear. So let us take one example and we'll discuss about its solubility and solubility product here. Here let us say I have a salt AXBY. Okay, so this is AXBY is a salt. So now this salt is sparingly soluble salt. So what I am saying, it is sparingly soluble salt. It means the dissociation for this salt is completely like 100%. It means AXBY will dissociate. See, AXBY, why I am writing this salt like this means, for example, I have a salt AgCl. Okay, so what is the A here? Our silver. What is our B? Chlorine. What is X and Y value? Both are 1, 1. Right? Now I am writing one more salt here, BaSO4. What is the numbers here? So this is barium cation 1. So A represent cation, B represent anion. So our B is what? Sulfate. Okay. So what is the number of cations we have? 1 cation and 1 anion. Okay, 1 anion. Right. So X and Y values are 1 and 1 in this case. Okay. Now like this, we will be having other compounds also. Okay, so sometimes we will be having Ag2CrO4. Okay, so in this case we have cations are 2, it means X value is 2 here and Y value is how much? This is completely anion. So cations are 2, this anion is CrO4 2 minus is, this is 1. So Y value is 1. So like this we should get clarity on the type of compound they are given. So I am generalizing the complete salts like AXBY. Okay, in order to make it more clear and more easier to understand and make a generalized formula. Okay, so now this salt will be undergoing complete dissociation, forms X number of cations and Y number of anions, because Y number of B are there now, Y anions. Okay, now let us say S is at time t0 initially, so S is the concentration of this, S is the solubility of this particular substance. Okay, so initially 0 0 will be there at initial case I am saying. Okay, now after some time t where this equilibrium is attained, so that time what happens, why I am saying equilibrium is attained, see I told you only some amount of salt will be dissolved, remaining will remains undissolved, right. So if you keep on adding also, some amount will again dissolve and the dissolved amount will starts precipitation. So this process is a continuous process, therefore that I can say that is a in dynamic equilibrium. If some amount is dissolved, some amount will start precipitation, same amount will start precipitation. So that is what the dynamic equilibrium here. Okay, now for example for a room there are 2 doors. So from one door some 10 people are going outside and same number of people will enter inside. So this process is a continuous process. If someone goes outside, equal will come inside simultaneously. So this is what the dynamic process. Same applicable here also. Some S amount is dissolved means S amount will precipitate after a particular amount of substance is solubilized. Okay, at T equilibrium, when this equilibrium is established, so S minus some amount is dissolved, na, that is S minus S alpha, this is the amount dissolved. Okay, so that will be only forming these ions, na, so I am writing S alpha here, here also S alpha, but how many, see for one ion 1A it is S alpha, but how many are there, that like that we have X number of S alphas are there, here Y number of S alphas are there. Okay, so just hold on for few more minutes, I will be explaining one example. At that time you feel relaxed because this might be making you confused, but wait for few more minutes, it will give you more clarity after solving one question. So I can write solubility product, it means the product of ions here after getting solubilized. So this is a cation, I have written, what is its coefficient, X, na, write in the power terms. Okay, so this is a anion minus X, what is its coefficient, Y, right here. Okay, so what is the value of X here, A here, this is a value, right, X S alpha power X, next here Y S alpha power Y, like this we should write. So here I told you complete dissociation taking place, but solubility is less. If it is complete dissociation, their alpha values is how much, their alpha values will be, alpha will be 1. So therefore something 1 power something will be 1 only, right. So I can ignore them, 1 alpha here. So we will get X power X, Y power Y from there, and S power X plus Y. So this is the generalized formula for finding KSP. Okay, you can write this formula. Remember X power X, Y power Y, S power X plus Y. So for example, I am saying a salt Ag2CrO4. Okay, now tell me, how can I write KSP for this? How many cations are there? So 2, right? So 2 power 2. How many anions are there? 1. So 1 power 1. Okay, and S power 2 plus 1. So 3. So 4S cubed is a formula, KSP formula for this particular salt. I hope it is clear. Now I am giving something like AB3 salt. So how can I write KSP for this? KSP is equal, simple, right? From this simple generalization. So cations are 1, so 1 power 1. So anions are 3, so Y value is 3, Y power Y, it means 3 power 3, and S power 3 plus 1, 4, that's it. So 3 3 is 9, 9 3 is 27, S power 4 KSP. This is how you need to write the interrelations. So I have generalized them. So take a screenshot of this. This might helpful for your understanding purpose. Like different salts, AB2 type, AB2 type, AB type, AB3, A2, B3 type. Like that we have salts here. So you can understand them from this slide. So let's have one question here. The solubility product of sparingly soluble salt, which is A2B, is this much. A2B is this much. Its solubility in mole per liter is, solubility product is given, KSP is given, very simple. KSP is given, they are asking value of S, very simple. So what is the formula for A2B? So I just now I told you now, we have generalized it. KSP equals to x power x, y power y, s power x plus y. So S represents solubility, Ksp represents solubility product. So what is the x value here? 2. So 2 power 2. Here y value is 1, y power y, it means 1 power 1. So S power x plus y, 2 plus 3, 2 plus 1, 3 you can take. Okay. So this is the thing which we need to consider here. I hope up to here it is clear. Then next here, Ksp value is 3.2 into 10 power minus 11, I am writing 32 into 10 power minus 12, okay, and 4 s cube. So 4 8 ja. So these I am writing 2 power 3, 8 I am writing 2 power 3 into 10 power minus 12 equals to s cube. Okay. So this cube get cancelling, and here minus 12 I am writing minus 4 because of this 3. Okay. So what is the s value? Finally we have 2 into 10 power minus 4. So this is a value we should getting as an answer. Okay. I hope this is clear. See, we have option B. Very simple questions these are. Okay. This many times are asked in the EAPCET exam. Okay. Very equally important for all EAPCET, NEET and JEE, for all the BITSAT, whatever the exam you are going to write on 12th base. Okay. Here, which are the following solubility of AgCl will be minimum? See, always remember, I told you AgCl, which is a covalent salt, which is a sparingly soluble salt. Okay. So it will dissociate to some extent, I mean soluble to some extent, and there exists some equilibrium between dissociated ions and undissociated substance, right? So now if we increase the concentration of Cl minus, what happens? Equilibrium moves backward. If we increase the concentration of Ag plus, it also moves backward. This is what the Lee-Chatterjee principle application. Na? So now solubility will be minimum. When it will be minimum? If we add any of these ions to this solution, then equilibrium moves backward, its solubility decreases. So look, is there any substance which is giving this type of ions? See, KCl, see Cl having common ion effect. So with this Cl having common ion now, so this is a strong electrolyte. So concentration is 0.1, which is having strong electrolyte, I mean Cl minus ions are coming from here. So when we add to this substance to this, so Cl minus ion concentration increases. So what happens to the equilibrium? Equilibrium favors backward, therefore its solubility decreases. So very easy, based on Lee-Chatterjee principle. So option B is correct. Then next, solubility of AgBr, having solubility product is this much in NaBr. Again this is also common ion effect. So they are saying AgBr is a salt, sparingly soluble salt. It will be dissolving like Ag plus and Br minus. Okay. This one having solubility product is this much. So Ksp of AgBr is given. So in NaBr, in this strong electrolyte, what is its solubility? What is the solubility of AgBr? They are asking. Now we know if this is a S concentration at time t0, this will be 0 0 initially. After some time t equilibrium, when this equilibrium is established, from this some amount will be undergoing dissociation. This will be S alpha. So 1 is there, 1 S alpha. Here also 1 S alpha. Alpha values are 1 because undergoes complete dissociation, means I am taking 1s here. Then what happens to Ksp? Ksp is equals to concentration of Ag plus concentration of Br minus. That's it now. Now to this what they are adding? So this is happening now in presence of NaBr. What is the concentration of NaBr they mentioned? 0.2. So we know NaBr is a strong electrolyte. Okay, so this will 100% undergoes dissociation 100% and gives Br minus ions and Na plus ions. So if it is having 0.2 concentration, its ions are also having 0.2 concentration, because one ion, these ions are completely coming from here in the 1:1 ratio. Therefore this Br minus ion concentration in this solution will be, should be considered to be this one plus this one. So 1s plus 0.2. But I told you, whenever we add a strong electrolyte to this weak electrolytes, its dissociation or its solubility decreases. So if it is decreasing, the concentration of Br minus is completely considered from its a strong electrolyte. So 1s plus 0.2b is considered to be 0.2 only, because it's the concentration of Br minus coming from AgBr is completely negligible when we compare with a strong electrolyte concentration. Okay, I hope this is clear. So Br minus concentration is 0.2 and we need to calculate this concentration of Ag plus, that is what the S dash, the solubility in presence of common ion effect. Okay, if we calculate this S dash, we will be getting the final answer. That will be our final answer. So what is its solubility product? 5 into 10 power minus 10. So I can write S dash equals to 2 into 10 power minus 1, okay, and this as 50 into 10 power minus 11. Okay, this minus 1 and this minus 11 I am writing as minus 10 itself. So 50 into 10 power minus 10 equals to S dash into 2. So now this 2 and this 50 becomes 25. Okay, just give me a minute, let me check. Yeah, is there any option? Yeah, so we have option number 2. So what is the value here? S dash solubility is 25 into 10 power minus 10. So this is our option number 2. I hope this is also clear without any confusion. Okay, so this is about the common ion effect. So will you give a try to solve this question? Like, so it's very simple. For CdOH twice is given in KOH. So again common ion effect, it's the molar solubility is asking this much, they are saying what is the X and Y values they are asking. Very easy. See, KSP is given. So whatever the steps I followed during this process, same steps you apply here, you will be getting the answer, and write in the comment box mentioning CdOH twice answer, like CdOH twice answer or last question answer as any of these options whatever you got. So if you are even going with the wrong answer, I will help you in the comment box, you just give me your answer. Okay, so just give it a try. So thank you for watching, happy learning.